So today we will be learning about functions in NLTK. So I will first give you an overview of what is NLTK. NLTK contains libraries and programs for applied mathematics language process. It's one amongst the foremost powerful IP libraries that contain packages to form machine perceive human language. So now, as we have already discussed NLTK before, so now we will be going with the basic functions in NLTK. So what is NLTK functions? So the functions that are included in NLTK are tokenizing, stemming, limitization, post tagging, and chunking. So first we will discuss about tokenization. Tokenization is essentially splitting a phrase, sentence, or a paragraph or an entire text document into smaller units, such as individual words or terms. Each of these smaller units are called tokens. Now, uh, for example, this is an example that this is Manisha. Then it will be broken down into this is and Manisha. So this is just a basic implementation of tokenization. So I will just show you what is tokenization through this example. So first, for implementing tokenization, we have to import NLTK. So first we will import NLTK using this command. After we import it, we as you can see, we will take a sentence from this database called book, and then we will be taking the sentence such as, and at 8 o'clock on Thursday morning Arthur didn't feel very good. So the tokenization, what it will do is basically it will divide the sentence into different parts and will tag it with its own tags and tokens. So first we will divide it into tokens from the sentences, and then we will tag it for its appropriate tokens. So after we run it, as you can see that this is a result that we will get, and this is the successful result of what tokenization is set to achieve. After that, moving to the next function, we will go with stemming. So stemming is the process of producing variants of root or base. Stemming programs are commonly referred to as stemming algorithms or stemmers. A stemming algorithm reduces the word chocolates, choco, to the root word chocolate, and retrieval retrieves reduce the stem retrieve. So it's basically what it does is it reduces a big word into a common word, which is like a base for all other words. So now stemming is an important part of the pipelining process in natural language processing. The input to the stemmer is tokenized words. And how do we get the tokenized words? Well, we learned that example in the previous function, and it involves breaking down the document into different words. Now, in order to show you a simple example of stemming, we will first go import the NLTK library as before, which we did, and now after importing the NLTK library, we will take a word known as for example civilization, and we will stem this word of civilization. As you can see, then it will convert the civilization word into civil. That means it is converted into a base word which can be used for other words such as civilization and other common words which are made from civil. And so this what we use in this was Porter stemmer. So Porter stemmer algorithm is basically a process for removing the morphological endings from words. So its main use is part of a term normalization process, and it is done for information retrieval system. In the next example, we will be going with the snowball stemmer. It is also a type of Porter stemmer only, but it is an advanced version of the Porter stemmer, and it is used to solve the faults that are commonly occurring in Porter stemmer. After running the example of snowball stemmer, we will get the same result, which is civil. That means our code is correct. Now moving to the next function, we will go with limitization. So limitization technique is like stemming, and the output of we will get from limitization is called lemma, which is a root stem, the output of stemming. After limitization, we will be getting a valid word that means the same thing. So NLTK provides WordNet limitizer class, which is a thin wrapper around the WordNet corpus. So in order to use limitization, we will use a class called morphe function, which is used with the class lemma, and now we will understand it with an example. So going into the limitization, we will first import these libraries into our system such that we can use the limitizer library. After importing these library, we will generate a function called limitizer with the WordNet limitizer class. Now implementing our own main code, we will implement the limitizer from the word Devincept. So after running this word, it will give us the answer as Devincept. So this is for a single word. But if we do it for a word which is if we do it for a sentence, then what it will do is first it will convert it into tokenizer. That is, it will convert it into an array of different words that are contained in the sentence. After that, it will join the all the array words into sentence based on our input. So in this input, we gave the input as a space in order to join all the words. But for example, if we can give for example, we can give as a comma, then it will join the whole words using comma. So as you can see, Devincept comma is comma, so it will do it like that. So this gives us an option to edit our sentences according to our choice. So this is what whole limitization is about. Now going further, we will be studying about post tagging, or we can say at POS tagging. So the primary target of part-of-speech tagging is to identify the grammatical group of a given word. So how do we know whether a word is a noun, a pronoun, an adjective, or something like that? So part-of-speech tagging helps us with that, and it is used in many softwares to identify, such as dictionaries, online dictionaries, and such softwares use this technique for clearly categorizing each word as noun or something like that. So now part of speech tagging is a process that mark up the words in text format for a particular part of speech. Now I will show you the part of speech tagging using a simple example. So first we will import all the libraries which I have given here. After importing these libraries, we will take a sentence. For example, I have taken the sentence as my name is Pranav. So we will first convert it into tokenizer, or we can convert it into a different words of array. Now after converting it to an array, we will use part-of-speech tag to convert these tokens into different or categorize it into different categories such as noun, pronoun, or some or like that. And after that, as you can see, I have characterized each word as a different adverb, a noun, or pronoun. Like here, a noun was my name and pronoun was my. So this is how you can use the part of speech tagging for categorizing your words. After this, we will use the in order to, like, for example, I don't know what a pronoun is. Then I can get a help from this library only to get more information about it. For example, I have taken here the help of taken the help using the pronoun library, and it gives me an explanation as that it is a pronoun and it is possessive, and also gives an example of how do we use it in our language. Similarly, we can use it for our other other processes such as for adverb or for noun or for noun and proper singular, everything like that. So this is how whole part of speech tagging works. Now further moving, I have also given here the abbreviation meaning of uh, all the adverbs and everything so that you can easily understand it. After that, we will go with the last functionality of NLTK, which is chunking. So chunking in NLP is used to take small pieces of information and group them into larger units. The primary use of chunking is making groups of noun phrases. It is used to add structure to the sentence by following part of speech tagging combined with regular expression. So the resulted group of words are called chunks, and in shallow parsing there is maximum one level between roots and leaves, while deep parsing comprises of more than one level. Shallow parsing is also called light parsing or chunking. So for the rules of chunking, there are no predefined rules, but you can combine them according to need and requirement. For example, if you need a tag, noun, or verb or adjective and coordinating junction from the sentence, you can use this rule as below. So the rule I have used is here this, as you can see. So now we will go with the simple example of this as well. So going for the chunking, first we will import all the libraries which I have mentioned here. After that, we can take any sentence such as I have taken the sentence as Devincept is a great place to learn. After that, we will define the grammar of which we want to take. So we have taken here these three grammars which we want to create as a regular expression. After that, we will first create a chunk parser using the regular expression parser here, and then we will implement the part of speech tagging in this. So as you can see, it has implemented a part of speech tagging, and it has characterized each word as a different what do we say, like different tag in these, as like Devincept is a noun and a proper noun. And after that we will parse the tagged word using the chunk parser. When we will implement this, we will create a subtree from this. So I have implemented a function such as subtree, and what basically subtree are the part of the whole tree which is created using the chunking process. After we run this code, we will get a subtree of this, like we are getting like we initially gave the word as Devincept is a great place to learn, and it has characterized into different adverbs, nouns, and everything like that, and it has created a subtree out of it. The subtree, as you can see, it is subtree. It is divided by a slash after each tagged word. So this is the whole process of chunking, and this is how chunking works. So I hope you guys have learned enough from this and from all the functions of NLTK, and we will continue to give you more input and information about this whole topic. And I hope you guys have learned enough from this. Thank you.